Hi guys! In this video, I'm going to discuss to you how to conduct paired samples t-test in JASP.
To illustrate how to conduct paired samples t-test in JASP, let me use this example. So in this example, I want to see if a certain supplement for weight loss is effective. So I have here weights of 30 individuals before and after taking the food supplement. And I want to use paired samples t-test to check if these 30 individuals have significantly decreased their weight. So now let's save this file in CSV format. So save as. Then be sure that the file type is in CSV or comma delimited. Okay, now let's open our JASP. To import the data that we have, just click the sidebar here, then click Open, then go to Computer and locate your file. Click Browse. Go to the folder where your file is located. Click the file and click Open. So I have now here my data. So we can see that I have two variables, the weight before and weight after of the 30 individuals. Now this is their weight before taking the food supplement, and this is their weight after 2 months of taking the food supplement for weight loss. So to check if the food supplement is really effective, I want to conduct a paired samples t-test. So I'll just click t-test, then click paired samples t-test, then put the variable here, and check for the assumptions, and check for descriptive. Okay, let us first look at the descriptives of this data. So in this corner, we have the descriptives of the two groups, the weight before and weight after of the 30 individuals that we have. So the mean weight before taking the food supplement is 80.93. And the mean weight of the 30 individuals after 2 months of taking the food supplement is 65.067. So from this descriptive table, we can see that their weight after taking the food supplement decreased. However, we are not sure yet if this difference is significant. So we have to conduct paired samples t-test. But before that, let us check the normality assumption. Now let's look at if the difference of the weight before and weight after is normally distributed. And let's look at this table for the Shapiro-Wilk test. Let us again recall that a variable is normally distributed if the p-value of the Shapiro-Wilk test is less than the level of significance. In our case, alpha is equal to 0.05. Now let's look at this table. And we can see that the p-value of the Shapiro-Wilk test for weight before minus weight after is 0.750, and this is clearly greater than 0.05 level of significance. So we can say that the difference of their weight before and weight after is normally distributed. So now we are ready to check the student for the paired samples t-test. And immediately, we have here the result. So let us recall, the two groups have significant difference if the p-value of the paired samples t-test is less than 0.05 or less than the level of significance. And this result shows a p-value of less than 0.001. And clearly, this is less than the alpha that we have. The p-value of the paired samples t-test in this example is less than 0.05 level of significance. So therefore, we can say that their weight before and weight after have significant difference. And we can further say that their weight after is significantly lower than their weight before taking the food supplement. And we can further conclude that this food supplement is really effective for weight loss.